Effect Schema is my favorite runtime validator, and I can't go back to something like SOD. But how does it set it apart from something like SOD? Well, I would say it's the bidirectional nature of Effect Schema. So in runtime validators like SOD, YOP, whatever, they are represented by this. You take in an input, which all of those libraries just defaulted from taking unknown and turning it into a structure, a type that you define in the runtime, but they omit entirely turning back this type into its input. Now, of course, this isn't particularly very useful if you have unknown as the input, because, well, how do you turn this into unknown? Well, that's the problem with those libraries. They just focus on unknown. They don't focus on other types. Let's say you have another type, so type A, and you want to turn it into type B and vice versa. So Effect Schema is centered around decoding, so taking an input type into an output type, and encoding, which is converting back the output type into the input type. And this is what sets it apart. Now, of course, there are other things. As you can see, you have arbitraries, you have JSON schemas, equivalents, but I would say the pillar of this library is the decoding and encoding nature and the composability. Everything is very easy to compose and also clear, which is important for that developer experience. So now let's see what this decoding and encoding means exactly. Well, I told you, decoding is taking an input type, so in this example A, into an output type which is B. And you also have encoding, which is the other way around. So you take the output type B into the input type A. But how can you see this in practice? Well, let's take this. You have a string, and this string can be JSON. So you need to decode it into a structure. So it could be an array, an object, well, whatever that this JSON can represent to you. But it can fail. So you decode an unknown JSON into a known structure. So you're validating at the runtime. But you can also take this structure back, so encode it back over to your JSON string. Now the encoding can also fail. What if this structure cannot be represented as a JSON? So just remember, decoding is taking an input into an output, and encoding is taking its output into its input. Now, what I'm going to show you in this video is based on my understanding and also the point of view of your typical consumer, not your maintainer. So there will be some inaccuracies, so do make sure to check out the official documentation, which for now is just this README, but it is incredibly exhaustive. I'll leave it in the description. So let's start with the very basics. I'm going to assume you have worked with libraries like SOD. So in those libraries, you should be able to just define a simple schema. So my simple schema is equal to schema. So we import schema from Effect Schema, and then you would say object, and then you would pass in the object. However, with Effect Schema, objects are structs. So remember, instead of object, just use struct. And then here you can define your properties. So you can say ID is a schema.string, and then you can say title is a string, and then is active, which is a boolean. Now, if we take a look at the schema, as we can see, we get this type, a schema.struct, and then the ID, title, and is active, which are just type of the schema definitions. But how can we parse data? Well, for that, you would say schema dot and then decode. So again, in our case, we want to take an input into an output. So here we can simply say decode and then pass in the schema. So my simple schema, and then this returns the decoder function. So when we invoke this, we can pass in the data that we want to validate against. Now notice how in this case, we need to input an object. And this object is exactly the one that we declared as the structure of the schema. So this isn't particularly very useful, is it? Well, it is actually very useful for it to validate at compilation what you're passing in when decoding. And the reason is because types just exist in TypeScript. The moment you compile it down to JavaScript, there are no types, and those types that you defined will never ensure runtime integrity. So this is incredibly useful when, say, you have an open API schema that you introspected, or you introspected a GraphQL schema, so you auto-generated the TypeScript types. Well, you need to ensure that your runtime schemas are synchronized when decoding with the actual data that is represented by those auto-generated types. So in that case, you can ensure that what you're decoding makes sense and you're not passing in something completely arbitrary. But you usually wouldn't do this. You want to take input which is unknown or any into this structure here. How can you achieve that? Well, you say decode unknown. And as you can see, we can pass in ID and title. Now, what do we get back? Well, we get back an effect that succeeds with the object and fails with a parse error. Now, I'm not going to focus on effect here. If you know effect, then you know how this works. But let's say you do not want to use effect and you want to mimic such result type, where you can check if result.ok, then I get the data. If not okay, I get the error. Well, for that, you can use either, and either is just a monad, similar to the result type that you would find in Rust, or to the option type. So an either is basically a left and a right. The left is usually, by convention, although it can be anything you want, the error. So in the left, you'd have all of the errors of a computation. And then on the right, you have the succeeding values. That's convention. Again, you can do it however you want. But this is great because we can check if the result is right, then we get the succeeding value. And if it's left, we get the parse error. So if I take a look at the type of X, as we can see, it is a little bit different. The left is the succeeding value and the right is the parse error. Now, this doesn't mean that effect follows the convention of left being the succeeding values, right being the error values. It's just the way they defined the type. And what they did was swap it at the type level, not at the runtime level, that left would be right and right would be left. Why? So that you can specify a right without specifying the left. So the left would default to never. Now, this is confusing. I'm not entirely sure these benefit outweigh the cons. If it's just because it saves you from typing out the left as never, then I would have never done this. This isn't the best for developer experience, but if it is for some TypeScript magic somewhere internal in the library, then it makes sense. Anyway, that means that we can import either from effect, and then we can say if either dot is right x, then we get the right, which is the same as saying x.data in sod. And then here you get access to the object. So ID is active and title. And if you do it the other way around, so here you get the left. And the left is a parse error. So here you get the issue, the name, the message, etc. So for demonstration purposes, let's just log x.left.message. Now we know that in this case, this will fail because we're missing is active. So if we run this, as we can see, we get this message. We get the structure of our schema, and then we get the error here. So it's active, is missing. So as you can see, it is very readable. But if we were to take is active and define it here, and then we were to log x.write instead, and then run this, as we can see, we no longer get an error and we get the object. So now let's say you want to have nullable values. So a union of, let's say, a string and null. How can you do that? Well, there are two ways to do this. The first one is by using union. So you say union, and then you pass in the string, and then you can say schema.null. And that's it. Now, if I pass in null to title and run this, as we can see, it succeeded. If I were to remove title, as we can see, title is missing, and we also get string or null here. But there's a more concise way of doing this, and that is by using schema, null, or, and then you pass in the string. Now those two are functionally the same, but well, this one is shorter. And now, again, if I run this, title is missing, string or null. Now, what about optional properties? So you know that in TypeScript, you can have a string or null, you can have a string or undefined. So this is undefined or, but you can also have the absence of the actual property. So in an object, you can have the title, which is optional, so it might not even be present whatsoever. Well, for that, you can represent it with undefined. Why? Because this inherently, by not passing in title, JavaScript will consider title as undefined if you try to access it. So if we were to run this, as you can see, it succeeds and the title is undefined. But if we were to say decode either without the unknown, we get a type error and we get title is missing in type. So now we need to come here and say undefined, which is not good. Well, for that you can say schema.optional, and that way you can pass in undefined, or well, you cannot pass it at all. And as you can see, it still works just fine. And if we were to pass in undefined here, as we can see, we get it here. So I like this convention that you have, well, null or, you have undefined or, and then you have optional, which is exactly the same convention as TypeScript. Now let's see how we can compose schemas. So let's say we want to add a filter. So we need to filter out all titles that aren't trimmed. Well, for that, you can come here and say schema.string, and then instead of piping it as you would with sod, where you say .filter, and then this returns itself, so you can chain it through, you have proper function composition. So you can say .pipe, and here you do the same. Except that instead of method chaining with dot notation, you just use commas, as simple as that. And then here you can say schema.filter, and then you get the value here. And then, as any filter does in any library, you know that it maintains the value if the condition is truthy. Otherwise, it removes the value if the condition is false. So for that, we can say we want to keep, so schema.where the value.trim is equal to itself. And now we can come here and then we can say ASD. And if we run this, as we can see, passed. But if we were to add a trailing white space and then save this and then run this, we get an error, predicate refinement failure. But as you can see, the message isn't the best, because it says expected string or filter actual ASD. Well, you can add the message here. So here you can say if it's different, then you can say value must be trimmed. And if not, you can return undefined. And if we run this, as we can see, value must be trimmed. Now if I come here, remove it, run it, everything works as expected. Now let's say we want to add a minimum length. Well, for this you can compose this. So you can just say schema.filter and then v, and if the value is less than, or should I say length, is less than or equal to 3, then we can say value must have a minimum length of 4. Otherwise we can say undefined. And if I save this and then run this, as we can see, value must have a minimum length of 4. And you can do the same for maximum length and whatnot. But obviously, all of this is a little bit cumbersome. You'd have to add these filters manually for every string, when these conditions are actually very common. Well, fortunately, Schema comes with its own utilities. So for the minimum length, you can say schema.minLength. And then you can pass in 3. And if I run this and change this to 4, as we can see, expected a string at least 4 characters long, actual ASD. Now if we take a look at the source code, as we can see, all it does is take in the schema, which is self, then pipes it through, and then filters it, and then simply checks against the minimum length that we pass in. But notice how it can take annotations. So you can come here and do a comma, and then you can say message. Now the message is a function, so you can say value must be at least 4 characters long. And if we save this, run this, as we can see, we get the message here. Now, why is this a function? Well, that's because you can get access to the parse issue. So you can say value must be at least 4 characters long, God, and then parse issue dot actual. And if we save this and then run this, as we can see, we get the message here and then God ASD, which is the input. You also have max length and other utilities that you can find here. Now, what about trim? Trim seems like a common use case. Well, for that, you can say schema.trimmed, which ensures that it is trimmed. And then you invoke this. And if I save this, come here, add some spaces. As we can see, we get expected a string with no leading or trailing white space, actual ASD. And if we come here to the function, as we can see, takes in the annotations and then takes in self, which is the function that it returns, pipes through self, does a filter, which is the same one that we were doing, and then it passes in the annotations, description, JSON schema, and some other metadata for the annotations. That means that we can provide our own message. So you can say message, and then value must be trimmed. And if we run this, value must be trimmed. As simple as that. However, this is once again another common use case, and maybe you want to just define this as the base schema, a trimmed string, without having to pipe this through and adding schema.trimmed. Well, for that you can say schema.trimmed, and now you can remove this. And if we test this once again, we get the error here. Now if we take a look at the source code, as we can see, it is just a string piped with trimmed, so nothing fancy. Now, what about transformations? What if you want to have this, where you say set.string and then you say .trim, and this will automatically trim the string for you? Well, for that you use transform. So you need to define the from and the to. So you decode from an input to an output and vice versa. So you can say trim the string is equal to schema.transform, and then we pass in the from. So from what? Well, from a string over to what? Well, another string. And then we can pass in an object and we get access to these functions. We have the decode. So here we do the input to output. So our output is a trimmed string. So we say x.trim, and then to encode it back, we can just leave it as x. Now this isn't the best because this decode is destructive. Once you decode it to a trimmed string, there's no going back. Sure, you can add these trailing white spaces, but the string can have as many white spaces. So this isn't accurate either. So for that, since it's destructive, we can just leave it as x. Or if you really wanted to, you could fail here and say, this schema does not support encoding, but we'll see that in a moment. And that's it. Now you can come here and say trimmed string. And now we can change this to minimum length 3. And if I save this, run this, it passes. And if I change this to 4, it doesn't pass. Now there's something important to consider when using transform, and that is when you say schema.decode, what it is going to do essentially is first validate this. So it will check that the input is actually of type string. Once that's validated, it will skip this for the time being, and it will come here over to the decode function, and it will trim the string. And once it has trimmed the string, it is going to validate that against this. So you have 2 total validations. So let me show you an example. Let's come here and say my schema, and this will be a transform, and we're going to take in a string, and then we want to transform this over into a number. So a number from a string. So we can say number, and then we can say decode, and then we take in the input and we say number of input, and then we can encode this and we can say to string. Now if we decode either, we pass in 1, 2, 3, we should get back a number. And as we can see, we get 1, 2, 3, as expected. But if we pass in an invalid number, if I run this, we get not a number. And that's correct, because not a number in JavaScript is ultimately a number. It is a subset of number after all. But if we come here and we pipe this through and then say schema.non-none, so not a number, which is just a filter, as we can see here, filter not number that is none, and then run this. As we can see, we get a parse issue. We get expected a number excluding none, actual none. But of course, there's a version of this as a schema, which already does the number for you. You can say none, and we get the same result. So as we can see, it is still validating this at the runtime. Now let's take a look at transformations that can fail when decoding and encoding, because there are different ways that your schemas can fail. So we know that the first one is the from. Well, if it's not a string, it will fail. Now after decoding, it is going to check against not a number. But what if the logic within your decode and encode can fail? How can you represent that? Well, for that you can use transform or fail. So let's say we want to take a string and convert it into unknown. And why? Because the string is JSON, or at least we expect it to be JSON. Well, for that you can say const JSON schema is equal to schema.transformOrFail. We take in a string, so we first validate against a string, and we want to convert it into unknown. Now you would be inclined to just do json.parse and to encode json.stringify. But remember, parse can fail, it can throw an error, and stringify can also throw an error. So we need to represent this at the schema level. For that, you can import from schema parse result, and then you can return parse result.try, which is a try catch block. So you have the try here and the catch here. So you can say the try will return unknown and it will simply json.parse. And for the error, you can simply say new parse result.type, and then here you get the options when parsing, and you get the AST. And then here you need to pass in the AST, the from, which would be the input. So this is the actual, and then a message. As we can see, it is optional, string, or undefined. So here we can say error instance of error. If so, error.message, otherwise failed to parse JSON. Now I'm pretty sure JSON.parse throws different types of errors, so you would have to investigate which types of errors and handle them better here. But for simplicity's sake, let's just check against error. And what about encoding? Encoding can also fail. So for that, again, we just say parse result.try, and then this returns a string. We stringify the input, and then in the catch, we do the same. Obviously, here you would check the different types of errors, I suppose parse error, and who knows what else. But how does this work? I mean, what does transform or fail expect exactly? Well, let's take a look at the try. As we can see, try returns an either, where on the right succeeds with unknown, and on the left we get a parse issue. This means that you can just do your normal try catch block and just return the succeeding value as the right of an either, so saying either.right, and then passing in json.stringify the value. And in the case of an error, you can just say left and then create the parse error, the parse issue. But well, this gives you the benefit of being able to pipe this through, since after all, it's an either. So you can pipe your ethers, call other functions, and I believe since either is a subset of effect, this should be able to accept an effect. So you could have some asynchronous encoding and decoding, but don't quote me on that. So now to use it, again, you just say decode either, pass in the schema, pass in the string. It is going to first validate that it is a string, and then it is going to parse it. And to encode it, instead of decode either, we can use encode either. and we pass in, say, a number. Although here you could pass in the result. So you encode back result.write. So we can move this within this if. And now if we run this, as you can see, we get the serialized JSON. So we get an object and we also get 1, 2, 3. But again, if we say result.write and run this, we get back the original data. So the output over to its input. So as you can see, you can just decode and encode accordingly. What if you were to pass in something that cannot be serialized into JSON? Well, for that, we can pass in a big int. And if we do this and then run this, as you can see, JSON.stringify cannot serialize big int. Now, how can we compose schemas with other schemas? We have seen schema composition with filters, although we know that that isn't the same as composing two schemas. We're composing a filter with a schema, but not a schema with a schema. How can we achieve that? Well, for that, we can use Schema.compose. And if we take a look at its type definition, takes in the to and takes in the from. Now, when using compose, you must remember one thing, and that is type conformance. So the from schema, which would be B, must extend the input type of the to schema, which is C. So what do I mean by this? Well, if I come here and say schema.string and we pipe this through and we say compose this with a number, this doesn't make sense. Why? Because type string is not assignable to type number. And that makes sense. We're validating here. We're not transforming one to the other. So we're validating that it is a string, but once it's a string, we compose this to validate that it is a number? That doesn't make sense. You need to first convert one to the other, and then you can compose it. So how would you fix this? Well, you need to say number from string. And now, since the output type is a number, we have type conformance for this schema.number. Although this is redundant because this already validates that it is a number. So for that, you could spice things up and say this should be an integer. And now it makes sense. So this is something that you should keep in mind. But in our case, since we're using a JSON schema, for example, we know that the output is unknown. So what can we conform this to? Anything, because unknown is like the parent type of them all, to put it that way, and all types are valid subsets of unknown. I'm not sure if that's how you define it technically, but it suffices for this example. So that means that we can create a structure such way that we compose a JSON schema with a predefined structure. So we can say const metadata schema is a structure, and then we can say width and then height. Now with this, you would be inclined to maybe move this over here to unknown. But there are two problems with this approach. One, now you need to return this shape here. So you would have to either lie to TypeScript and mark it as any, so you can let a schema validate it here, or you can do parts of the validation here and then let a schema do it here. Again, defeats the purpose of using this type of schemas. And the second problem of doing it here is you lose composability. So let's say you have multiple parts in your application where you need to validate that something is JSON. So what are you going to do? Are you going to copy all of these functions, create a generic wrapper for these functions, complicate your life even more? Well, no. For that, you would compose it. So you would take this schema as is, as generic as possible, and then all of your consumers can just use Schema.compose and compose it accordingly. So how can we do that? Well, we can say JSON schema.pipe and we compose this with the metadata schema. So we're taking unknown and we're validating it against this object. So now we can say const compose the schema, and then let's do a test case And if we run this, as you can see, we get width is missing. And if we change this to a valid structure and then run this, it passes and we get back the object. But we can refine our schema even more. So we can say none, so not a number. And then we can pipe this and then we can compose this with an integer. And we do the same here. And I believe we can even say positive and do the same here. So now we can run this once again. They pass. But if we input something that isn't an integer, fails, expected integer, actual 100.5. And what about a negative number? Expected a positive number, actual -10. Now what about discriminated unions? What if you have a discriminator? How can you represent that here? Well, let's add a version here. So version, and we can say literal. So schema.literal, and then we can say 1 or 1.0 if it's a string, whatever. So this must be 1, and then we can create another one. So let's call this v1, and then const metadata schema v2, and then it includes the depth, and then we can come here and say compose this with a union of version 1 and version 2. And notice how you do not need to specify the discriminator. It's just a union. It can already internally work out the discriminator. And now, if we were to run this, we would get an error. Version is missing. So we can come here and say version is 1. And if I save this and then run this, as we can see, expected a positive number. And if we run this once again, we get the object. But if we take a look at the result, so the write, and then say version, as we can see, we get 2 or 1. And not only that, we get the common properties. Version 2 also has height and width, and we know that since it's a union of the two, either way we're going to get back the height, version, and width. But if we check the version, so if it's equal to 2, then TypeScript should be able to narrow the type down, and as we can see, we get access to depth. So if we come here and say 2, add some depth, as we can see, everything works just fine. Now what I like about Schema is being able to normalize data and make it conform to your conventions. So for example, your application uses camel case, no snake case or Pascal case, whatever, but your API returns the data in snake case. How can you rename those properties? Well, for that you can pipe this through and say rename, and then you pass in the object, and then you can target the properties. So you can rename updated add to camel case, and the same with created add. So it will first validate everything with this structure, and then it will proceed over to transforming the output of this over to this new schema, which is the renamed schema. So now when you decode this, so decode sync, this will throw an error, and then you say to do schema, and then you pass in some data. For now, let's ignore these TypeScript errors. As we can see, the result is now completed add, or should I say created add and updated add in camel case, which is absolutely great. And if you encode it, you now take in the output data, and as you can see, it is now back to its original shape. But now we have a second problem. The API designers don't know how to use JSON, and since they are unfamiliar with JSON, they like to nest things and provide keys. So they say items, and this will point to the array of to-do schema instead of just sending an array of the to-dos. And you're not a fan of doing result.items and then mapping over them, but you have many system boundaries that can get access to the to-dos, maybe a WebSocket connection, the part where you fetch them. You may have other components that maybe just show a subset of the data. So you have a lot of places where you're getting back the data in this exact shape with this unconventional response structure. So you want to prevent making all consumers remove the items and just return the array, because you're duplicating code. So for that, all you need to do is say Schema.transform, and this is the from, and then you can say to what? Well, to just an array of to-do schema. And then to decode it, you simply say response.items, and to encode it, you get the items, and you return an object with the items. But now you get a type error, and if we take a look at the type error, we get strict is missing. So this simply ensures that whatever you're returning from the code and encode conform to the types of these schemas. So you can disable this if you trust in yourself, which I wouldn't advise, or if it's not possible to have a strict, but that only applies in certain scenarios. You would have to use a schema to start seeing when having strict false makes sense. But anyway, if we add a strict, we now get another error, and we get this array here. So as we can see, completed, created at camel case, updated at camel case is not assignable to these two snake case. So what is the problem here? Well, we're transforming it from this structure, and then we're renaming it, and we're doing it all as the first step of the decoding. But then we say that we want to transform this into an array of to-do item schema. But the problem is that since this is a composed schema, we're expecting first this snake case, and then we convert it over to camel case. So here we have already converted it over to camel case, but this one expects the snake case. So we're getting an error because we're passing the already renamed schema over to the 2 of the transform. So what can we do here? Well, you can do two things. The first one is to move this pipe over to the 2. So now we get the original data here, then we decode it, we extract the items, and then schema will go one by one and rename and revalidate everything. Now, if your schemas are complex enough, this is completely valid. However, I wouldn't do this. Why? Because you're doing twice the computation. You're first validating this structure, you are iterating over each item, validating it against the item schema, and then once you decode it, you're going to validate everything again. So you're wasting computation, especially if you are validating hundreds of thousands of items. So what can you do in this case? Well, we can move the pipe once again over to the schema, but we can say Schema.typeSchema, and now the error goes away. But if we take a look at TypeSchema, as we can see, allows you to extract the type portion of a schema, creating a new schema that conforms to the properties defined in the original schema without considering the initial encoding or transformation processes. So what does this mean? Well, that means that it will ignore this base initial decoding and will just consider the final version. So that's why we get no type errors, but also it will not run anything at the runtime. It will not validate anything because after all, it's a type schema. Similar to types in TypeScript, they're just enforced at the compilation level, but not at the runtime. So let me show you a real world example. Let's say you want to log in with Cognito, change your password, etc. Well, they send the errors in the headers, not in the response body. So for that, they come with the colon. So basically limit exceeded exception and then a trailing colon and so on. But I needed to normalize this because I had some problems with internationalization. The library I was using was removing the colons. So when I tried to match them over with the keys in my internationalization files, it wouldn't find anything. So I had to remove them. So for that, I just defined all of them here. And then I did a Schema.Literal. I spread over all of the errors. I added the colons because these are the original errors. So I need to parse these errors. And then I say transform over to what? So this is the 2, because this will implicitly take self, which is given to us in the pipe. So here I say, well, the header errors I want, and then to decode them, I just replace the colon, and I need to assert this. And to encode it, well, I just now wrote down the type with 2. Why? Because it already knows the type here. So TypeScript knows that if we add the colon and then use as const, then it will conform to the original type, which is the input, and well, for the output, fortunately it doesn't have that much information, so we need to assert it as I said before. And I say strict true, so I make sure that at the type level everything is okay. And then I did the same, I got the header here, pointed it to the schema, and then I can just rename it over to error type, as simple as that. Look how elegant this is. Achieving this with SOD would be way more boilerplatey and also not that composable, so this is why I love effect schema. Now what about error paths? What if you're using React hook form? Well, take this schema for example. We have a password schema, so we take in the password and the confirm password, and we have some validation. So first we check that it is trimmed, so we do not use the trim variant because this automatically removes white spaces. We want to make this trimmed because as far as user experience goes, it would be really bad for the user to type out their password with trailing white spaces, thinking that it is valid. Maybe they save it over to Bitwarden, and then when they try to log in, whoops, doesn't work. So it's better to give feedback like, hey, it must be trimmed, no trailing white spaces. And we say minimum length 8, although now that I think about it, this regex is checking that for us, so this can go. And all we need to say is pattern, we pass in the regex, and then we can pass in a custom message. This simply checks that it is at least 8 characters long, can contain letters A to Z, including capital letters, numbers, and the special characters. And then we say schema.redacted, so it will transform the string over to the redacted type. Now, if you have no idea what this redacted is, make sure to check out a video I just released about it. It is incredibly useful. Doesn't take you more than 5 minutes to learn all about it. And then the confirmed password is just a string. Why not the same validation? Because this field depends on this field. We need to check that the confirmed password is the same as the password. So why add all of these validations when ultimately it's just a simple comparator of strings? Or comparison, should I say? Well, for that, you need to also specify the path, so that if you're using React hook form, it is going to show the error at the confirmed password, and not just fail with a generic message rendered who knows where. Well, for that, you can pipe this through. You can say filter, you take in the input, and then you can say if it's different, then you can return an object, and you can say path, so confirm password, and then message. Passwords do not match. Now, since we're using redacted, we can import redacted from effect, and then we can say redacted.value. And also do the same with this one, so this one should be redacted. And that's it. This is how you can do it. If you're working with an array, you can also pass a dynamic path, so confirm password, then .index, just like React hook form expects it. Well, you can do everything that SOD does and even more, and the composability is way better. So from now on, I'll stick to effect schema, and I hope you do the same. Anyway, this wraps up the video. I hope you learned a lot, and if you want to see more content like this, make sure to subscribe and like the video. I'll see you in the next one. See ya.